Welcome to AIAG Control Plan Simplified Audiobook. Presented by MBB Biswanath Subhash Panda, subscribers can download the Control Plan checklist in PDF and Excel formats. If you enjoy this audiobook, please share it with others, subscribe to our channel, and give it a like. Summary Chapter: Control Plan Introduction. The Introduction chapter explains the purpose and structure of the control plan methodology used in manufacturing. Its main goal is to help produce quality products that meet customer requirements by providing a structured, systematic approach to identifying and applying value-added control methods. Control plans are living documents intended to evolve in response to changes in process, product design, or feedback from audits and customers. They describe control activities across all stages, including receiving, in-process, outgoing, and periodic checks, to ensure processes remain in control. Control plans may also address rework processes either directly or through separate plans. While they do not replace operator work instructions, control plans support broader quality efforts and ensure consistency in execution. The chapter also outlines the book's structure, which includes detailed chapters on requirements, development steps, various phases, prototype to production, and effective use, along with helpful appendices. The introduction stresses alignment with customer-specific requirements and integration with broader quality management systems. Summary Chapter 1: Control Plan Requirements and Guidelines. This chapter outlines the essential requirements and best practices for creating, maintaining, and utilizing control plans effectively in the manufacturing industry. Control plans serve as living documents that ensure process consistency, product quality, and alignment with customer expectations. The format must include key data points, such as special characteristics, error proofing, reaction plans, and visual inspection protocols. It also addresses pass-through characteristics, family control plans, and interdependent processes, ensuring comprehensive coverage across complex systems. Rework and repair activities must be clearly defined, with traceability and customer approval where needed. The chapter emphasizes the importance of updating control plans in response to process changes, feedback, or corrective actions. It also emphasizes the importance of collaboration with customers and suppliers, especially in black box processes, directed supply, or when the organization is non-design responsible. The use of software tools for control plan management is encouraged to enhance accuracy, consistency, and integration with other quality documents, such as FMEA and flowcharts. Summary Chapter 2: Control Plan Development. The chapter Control Plan Development explains how to develop a robust control plan as part of the overall product quality planning (PQP) process. Its primary goal is to ensure consistent and timely communication and execution of all required controls to meet customer expectations and enhance product quality. The development begins with organizing a cross-functional team, defining the scope, and aligning with the APQP timeline. Effective coordination with APQP teams is essential to ensure milestones, inputs, and outputs are aligned and well documented. Inputs for the control plan include risk analyses, DFMEA, PFMEA, design documents, engineering drawings, process flow charts, special characteristics, and quality history. Each element helps identify critical product and process characteristics requiring monitoring and control. The plan uses detailed methods to define specifications, measurement tools, sample size, frequency, and control methods, all tailored to reduce variation and enhance capability. Special emphasis is placed on identifying special product and process characteristics, using worksheets and cross-referencing documents for traceability. Reaction plans outline immediate actions when issues arise, assigning clear responsibilities to prevent recurrence and restore process control. This structured approach ensures all stakeholders, from operators to engineers, are aligned, and the control plan becomes a living document that evolves with the product and process life cycle. Summary Chapter 3: Control Plan Phases. This chapter outlines how control plans evolve through 3 key phases: prototype, pre-launch, and production, each with distinct roles and deliverables. Prototype control plan defines dimensional, material, and functional tests to be conducted during prototype builds. Supports early customer feedback, establishes preliminary process parameters and packaging, and flags any deviations or cost concerns. Pre-launch control plan activates after prototype and before full production. Adds controls such as error proofing, data collection for early capability studies, and systems for containing non-conformities. Data supports key APQP outputs like measurement system analysis, preliminary capability studies, and production validation testing. May include safe launch additions per customer requirements. Production control plan establishes long-term systems for process and part control. The launch begins with an enhanced safe launch period, featuring tighter inspections and monitoring. Criteria, often a defect-free window, e.g., 90 days, determine transition to steady-state production. The plan remains a living document, updated using production data, FMEA revisions, new technologies, customer feedback, and best practice learnings to ensure ongoing process control and improvement. Summary chapter for our effective use of control plans. The chapter Effective Use of Control Plans emphasizes the control plan as a dynamic, living document central to a robust quality management system. It highlights that control plans must evolve with continuous improvement, corrective actions, and lessons learned. Tools like reverse FMEA help identify process gaps, while software enhances real-time integration across FMEAs, control plans, and work instructions. Layered process audits, LPAs, verify the effectiveness of controls at multiple organizational levels. The chapter also addresses modern challenges, including control in highly automated systems, abnormality management, and risks associated with storage and handling. It promotes the use of family and foundation FMEAs for efficiency and consistency. Importantly, it encourages early identification of risks, system-level thinking, and proactive mitigation strategies. The guidance provided is rooted in best practices. It supports integration across product lifecycle phases, ensuring that control plans are not isolated documents but are core to delivering consistent, defect-free production. We'd love to hear your thoughts. Share your feedback to help us improve, and let us know in the comments if there's a specific book topic you'd like to hear next. Thank you very much.